Yes, welcome to the today's homework part from the capacitance chapter, practice book, level 1, question number 10. Consider a capacitor 10 microfarads is charged to a potential of 500 volts. So this is of our capacitor is connected to a 500 volts battery. So this is 10 microfarads capacity and this is 500 volts, and the charge stored on this Q is equal to C into V. So that I will say C1 V1. So this is of our C1 and this is of our V1, initial potential and capacitance. So that is 10 into 10 to the power of minus 6 into 500. So we will get this 5 into 10 to the power of minus 3. So this is the meaning of the first sentence. Its terminals are then connected to those of an uncharged condenser of capacity 40 microfarads. So another is connected here with a 40 microfarads capacitor. I think this is not a 40 microfarads. This is 10 microfarads capacitor. Now, so again he's connected like this now. So same capacitor. This is of our original capacitor of I'll taken as a C1 is equal to 10 microfarads. So this is connected to another capacitor. So with the same potential, so that is again 10 microfarads. So this I will say C2 now. So here in a parallel combination, so in parallel combination, so potential is same. Potential is same and charge will be conserved here. Q is equal to Q1 plus Q2. So that is initially we got the Q is 5 into 10 to the power of minus 3. That is equal to Q1 means C1 into V plus C2 into V. So C1 value is 10 into 10 power minus 6 into V, and C2 value is 10 into 10 power minus 6, again V. So this is 5 into 10 to the power of minus 3. So then from this V we will get 5 into 10 to the power of minus 3 by 20 into 10 to the power of minus 6. So that we are going to get here. So 2.5 into 10 to the power of 2. It means that 250 volts. So we'll take this is V1 now. This I will take as a V2. Let me to say this is V2. So then now from this, what is the change in energy? So our initial energy is half C1 V1 square AC minus, this is of our initial energy, and final energy is half C1 V2 square minus half C2 V2 square. So this entire part is of our final energies. So then from substitute all the values, half into C1 value is 10 into 10 to the power of minus 6 and V1 is 500 square minus half C1 value is 10 into 10 power minus 6 whole into here is a 250 whole square minus again half into C2 is value also is 10 into 10 to the power of minus 6 and V2 value is 250 square. So then take a common part here, 1 by 2 into 10 into 10 to the power of minus 6 common part in all these. So then left is 500 square. So this is 500 square minus 250 whole square minus 250 whole square. So solve this entire, then you are going to get 0.625 joules. So just we have taken the formula here. Change in energy is equal to initial energy minus final energy. Yeah, we'll go for the next one. So next question, question number 9 in a practice book. Practice book level 1. An isolated parallel plate capacitor stored an energy U naught is equal to 10 to the power of minus 3 joules is nothing but an Q square by 2C is a formula for this. In the absence of dielectric, if the dielectric epsilon r or else k is 10 is introduced, find the energy in the capacitor. So whenever we introduce an dielectric, then energy will become here q square by 2 into kc. This is equal to u naught by k. So then from this u naught value they are given is 10 to the power of minus 3 and k value dielectric constant 10 they are given. So this will become a 10 to the power of minus 4 joules. So if you introduce a dielectric constant, then your energy will become an 1 by k times. Then we'll go for the next one. Now, come to the same practice book, level 1, question number 10. A 10 microfarad capacitor. So what is a C value here? 10 microfarad is nothing but a 10 into 10 to the power of minus 6 farads is charged to 100 volts. So potential V is equal to 100 volts. Then the plates are joined through a resistance. The heat produced in the resistance in joules. So he wants the heat produced. So that is nothing but energy stored in a capacitor. Energy stored in a capacitor. So what's a formula for us? An energy stored in a capacitor, that is half CV square. Then substitute the values now, half into C value 10 into 10 to the power of minus 6 into V value is 100. So then this will become an 1 by 2 into 10 to the power of minus 1. So this is 0.5 into 10 to the power of minus 1 is nothing but a 5 into 10 to the power of minus 2 joules. So here heat stored is nothing but is in the form of energy or nothing but a work done.